Okay, for 8.4, we're still finding sums, but this time we have infinite geometric series. So it means it's multiplying by some number to get to each term, to the next term, but these ones go on forever. There's no set number of terms, okay? And I want to first look at these following infinite series in these pictures. So if I were to like connect this right here, okay, it's flattening off at 1, okay? So if I were to do the sum of all these fractions and infinitely go, it's going to equal 1. This one, if I would find all these sums of all those fractions infinitely, keep going, forever and ever, it's actually going to add up to 0.4. Now this one, it's going to go up forever and ever and ever. It's not going to have a sum, okay? And so the rule for that is if R, which is your common ratio, what you're multiplying by each time, if it is greater than 1, which you see in this last picture here, I'm going to multiply by 3 each time. That's greater than 1. It has no sum, okay? If R is less than 1, which in this one it looks like I'm multiplying by a half, well, so is this one. Both of those are less than 1, and it's the absolute value. If they're negative, that doesn't matter. You're really looking at the number itself. So absolute value of R, is it less than 1 or is it greater than 1? Okay, greater than 1, your answer would be no sum. Now, you can still calculate an answer. You would just be wrong. So you have to look at R first. Is R less than 1? If it is, then go through the process of finding the sum. If R is greater than 1, stop. Just write no sum. Okay? And so this is the equation that we'll use. It's the first term divided by 1 minus R. All right. So what we're going to need is we need A1 and we need R. And that's it. So when I'm plugging it in, so remember that equation, the sum was the first term divided by 1 minus R. Okay? So if I list A1 is 3, R is 0.7, and I'm going to check that it is less than 1. Okay, it is. So I can go ahead and then plug into my equation, okay, because it's true that it is less than 1. So my sum for infinite terms here is 3 divided by 1 minus 0.7. And again, if you're putting this in your calculator, make sure some parentheses around that denominator, and you get 10. Okay? And then number 2, whoops, again, the only things we're needing are A1 and R. A1 is 3, R is 5/4. Okay, before we move on, we have to check. Is it less than 1? Nope, it's not. It's actually greater than 1. It's 1.25. So this one has no sum. I'm not even going to continue calculating. Okay? You can calculate, I mean, you will get a number, but it's not the true answer. Okay? So you have to check R before you use the formula, or you'll get an answer that's not actually the answer. So it's one of those rules you just have to pay attention to before you start trying to solve, okay? And now number 3, this one's not giving it to me in summation notation, okay? But I still need A1 and I still need R. Well, A1 is 1. Looks to me like I'm multiplying by a negative 3/4. That is, if I check the absolute value of it, is less than 1, so we're good here. So I can plug it into my equation. The sum of infinite terms is A1 over 1 minus R. Remember, minus a negative, you're going to end up with plus a positive, and make sure that's in parentheses, and you get 4/7. And that's how you're going to find the sum of infinite geometric series. Again, double check R each time before you start trying to solve.